All right, this video is for 16.2 lesson. So we are going to be working on some different ways of displaying data. So we kind of talked about that a little bit yesterday, right? We can make lists, tables, dot plots, histograms. We're going to talk about a different way today. So first, we're just going to get used to analyzing some data. So if you have not already tried the Spark, actually, maybe you'll want to watch this first. I'm going to tell you right now, if you'd like to use a calculator for some of this, that is totally great today. So calculator, if you want to use it, go for it. So this tells us that Slavic is looking to buy new clothes for his best friend's weekend-long celebration. He wants to get the most for his money, and he's gone to 7 stores and made a list of the prices for jeans, dress shirts, and sports jackets. So he has $160 to spend. He needs to buy one of each item. What combination of items best fits his budget? So now one thing we want to know is that he doesn't just want to necessarily buy the cheapest stuff, right? Sometimes if you buy cheap things, they're going to break. You're going to have to just buy them again. So he wants to spend as much of his money as he can. Sorry. And he also doesn't have to shop at just the same store. He does not just have to go to Dress to Impress. He can get his jeans from Addie's Fashions. He can get his dress shirt from L&P, his sports jacket from another place. So go ahead and just try some different combinations and see where could he get his jeans, his dress shirt, and his sports jacket from that are as close to 160 as you can get. He wants to get the best quality for his money, and tell me where you got them from. So after that, we want to find the median for each item. So we're going to put these in order and then find the middle. We're going to put the dress shirts in order, find the middle, put the sports jackets in order, find the middle there. So now this is where you might want a calculator. So it's finding the mean. So if you want to use your calculator and add these up and divide by 7, add these up, divide by 7, add these up, divide by 7. That is totally fine today. So you're going to find the median, find the mean, and then you're going to think about why Slavic chose to spend more money. Why might Slavic choose to spend more money than only buy from Haley's Superstore? So if she goes to Haley's, right, he doesn't spend a ton of money, but right, maybe those aren't going to be the best quality. Maybe they're not in style. Maybe he just doesn't like them. And so sometimes it could be worth it to spend a little more money to maybe get a better quality. Maybe Haley's Superstore is kind of far away from his house, not very convenient to him. So yeah, there can be a lot of different reasons why we spend more money than other times. So as you're looking at these different things here, so I noticed as I did this that the mean for the jackets went down, the mean for the dress shirts went down, but then the jeans actually went up. And so the mean got higher. And this also, like these two, the jeans and the dress shirts were very similar. And then I can see the sports jacket is going to be where he's going to spend more of his money compared to the dress and the jeans. So this information, as we find these things, just gives us more facts and helps us make better choices. So, right, he's going to need to know, okay, so maybe I get a nicer jacket. I'm going to have to spend less money over here. So it just helps him consider different options he has. So when you are ready to do task 1, let's jump in. So our goal today is that we are going to be able to draw a box plot. So we've talked about dot plots, histograms. We're going to do a box plot today. This sounds really nerdy. These are actually one of my favorite things to do in math. So I think they're kind of fun. So you can also find them. So if you can find the median and the quartiles, which we'll talk about, of the data and just find those, that's the 2. And then if you can draw it into the plot correctly, that's the 3. And then if you can understand what that is telling you, that's the 4. And if you can just find the median, that's the 1. And I think we can all do that. We can put the numbers in order, find the middle. So we're all here. So we're going to work on finding these quartiles today and then putting them into a box plot. So a box plot is a graph that shows how data is distributed, so how it's spread out. So we find the median, we find these quartiles, which we'll talk about, the smallest value and the greatest value. So when you hear the word quart, what does that make you think of? So personally, when I think of the word quart, I start thinking quarters. There are 4 quarters in a dollar. There are 4 quarters in a year. We lots of times break it up into different, like 3 months, like 4 seasons. So the word quart makes me think of 4. And we are going to be finding the 4 sections of our data. We're going to be breaking them up into groups of 25%. 25, 25, 25, 25 is 100% of the data. So we're going to be looking at the lower quartile, which is the bottom half of the data, or the smaller numbers. And then we'll also be looking at the upper quartile, which is the larger numbers. So for example, so if I have the numbers, I'm going to type really quick, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my data, and I want to break this up into 4 equal sections. So I find the middle, here's there. So this is called the median, or quartile 2, right? 2 is half of 4, it's halfway into my data. Then I look at this section here, and I find the middle of this, which is here, 2.5. So that is quartile 1. So here's the first quartile. Here's the second quartile. Then I find the upper quartile, middle, so 7 and 8 makes 7.5. Whoops, I wrote that. Let me write that on the top so it matches, 7.5. So that's called quartile 3. And then the end here is quartile 4, but we just know it as the end. So right here's the beginning. So here's 1 section, 2 sections, 3 sections, 4 sections. They all have 25% of the numbers inside of their section. So that's what we're trying to do, is break these up. And now not all numbers are just going to go nicely in order. So as we are making these box plots, some of ours are going to be spread out, some of them will be squished together. And that helps us understand where the data is concentrated. So if you're taking a test and I grade it all and put it on a box plot, I'm going to hope you're all concentrated at the higher numbers, that you did really well on it. But maybe for Slavic's jackets, he's going to hope the numbers are concentrated on the lower end and packed together, because that means he has more options that are a lower price. So these box plots just really help us understand where is the data occurring. So just another way to look at them. So let's take a look at an example of a box plot and compare it to our dot plot here. So here's our dot plot. Here is our box plot. So they represent the same information, but they do it with different facts about them. Some of the things are the same. I can find the median on both of them. It's a lot easier to find the median here because it tells me that's the median. And on here, I'd have to go back and forth and find it. I can find the quartiles on here, but this one just tells it to me. I can see the minimum is 1 and 1. The maximum is 9 and 9. So they do both tell me min and max very easily. But this one tells me some more information easier than over here. But this one tells me, right, there's 2 people that had 2, 5 people that had, or 3 people that had 5, 2 people that had 8. Where over here, I don't know how many people had 2. It doesn't tell me that. How many people had 4? I don't know that off of here. So this is good when I want to identify individual information. And this is good when I want to look at the information as a whole piece, right? I can see 25% here, 25's here, here, and here. And the closer they are together, so this box is bigger than this piece here. So I've got more numbers here than here. So it's just telling me where are they packed together. So let's go ahead and practice that with task 1. So we're going to find the median, the lower quartile, and the upper quartile. So the first thing we want to do is put these numbers in order. So take a second and put those in order, and then come back when you are ready to check that out. So I can see here is 40, and then we've got 54, 69 looks like my next one. Oh, that was a crazy one. 78, then 85, 89, and 95. So we want to find the median first. So I go through and find the middle. Here is 78. So there's my median. Now I already used this 78, so I don't give it to either side. It's been used. Done. So I look at the other halves of the number. So here's my first half, and I find the middle. Right here is quartile 1. And then I look at my upper half. Here's the middle, quartile 3. So you're splitting your data in half with the median, and then you're finding the median of the first half, the median of the second half. So here's the middle. So I can see here's 1 section, 2 sections, 3 sections, 4 sections. So we are not actually going to create our box plot right now. So we're going to skip that guy. So we can see, right, here's 78. My smallest value was 40. The greatest one was 95. So we can fill all of that information out. So go ahead and complete task 1, and then come back when you are ready to do task 2. So task 2 is telling about some heights of roller coasters. So we have 10 roller coasters, and we are going to put these in order here. So the first thing we want to do is get these in order. So go ahead and do that, and then come back when you're ready to check. So my smallest roller coaster looks like it's 35. And then actually, I'm going to magically pull this up. There they are. Okay. So 35, 42, 42.5, 60, 60. So 2 roller coasters are 60, 76, 78, 79. So lots in the 70s, 80, and then, or 81, then 100. So we want to start and find the middle here. So 35 matches to 100, 42 and 81, 42.5 to 79, 60, 78. So we've got these 2 numbers here in the center. So to find the middle, we're going to add them up and then divide by 2. So go ahead and do 136 and divide by 2 here. So that goes in there 6 times and 8. So my middle is 68. The median is 68. Now, if you'll notice, we did not actually use the number 60 or 78 as the actual median, right? If we come back to this one, it had an odd number, 1, 2, 3 on this side, 1, 2, 3 on this side, 1 in the middle. It was done. We didn't use it again. We didn't give it to either side because we want to keep them even. But on this one, we split this. We found the middle of 60 and 76. So we actually do need to give this 60 to this side. So if you look here, let me erase my line up and giving 60 to this side, and then 76, we're giving it to that side. So if there's just 1 in the middle, just circle it, it's done. But if there were 2 in the middle that you had to find the median of, then we've got to break it up and give 1 to this side and 1 to this side. So now we're going to find the median here. So 35 matches 60, 42 matches 60. So here's my Q1. And then 76 matches 100, 78 matches 81. Here is Q3. So now using that information, we're going to put it on a number line. So I draw a vertical line up and down where I want the median at 68 is here. Then I find my quartiles. So the smallest one is 42.5. So here's 40, 41, 42 and a half. And my upper one is 79. So you take your median and then the middle of the first half, the middle of the second half, and we're drawing 3 lines there to represent those. So this is where your box comes from. So here's my box. And then it also has these little whiskers coming off of it that says here is the smallest roller coaster and here is the highest roller coaster. So your median is the middle line, your quartiles are the end of the boxes, and then you have little whiskers that say the smallest and the biggest number coming off of your box plot. So I can look at this and see that this segment here is much shorter than this one here. So that's telling me that 25% of my data is pretty close together, right? There's quite a few roller coasters here to here. These ones are pretty spread out here. So to get here, there's still 25% of the roller coasters, but there's just not a lot of roller coasters that are between, right, that middle section. Then there's more, 25% are more packed together here. So it's going to be a lot easier to find a roller coaster in the 70s than it is, say, that goes up 50 feet. So if I just kind of want like a medium roller coaster, I'm going to have to look a little harder. So there's some smaller ones that are pretty easy to find. There's quite a few smaller ones. These medium-sized roller coasters are going to be harder to find because that data just is more spread out. There's just not as many of them. This one's a little more packed together. So I could find like a challenge roller coaster here, like a harder roller coaster. And then these are kind of like our expert roller coasters. It's a little more spread out. It's going to be harder to find a roller coaster that goes up above 80 feet. So it's telling me they're possible, but because that line is spread out, it's just saying there's not as many of them in that section, right? They're more concentrated in the 70s here. That's going to be a lot easier to find a roller coaster that has a height of 70. We can see that, right? 3 of the roller coasters in the 70s are packed together. So now one thing I want to ask you is, why do you think we should put this on the box plot on a number line? So let's take a look at what happens here if I put my data up on this, just my line of numbers. So here's the middle, here's my quartile, here's my quartile. So I connect my box, and here's my lowest or highest and lowest. So what differences do you notice here? So one thing I notice is that this one, right, they're all pretty much equal. And we know that's not true. It makes it kind of distorted and not correct. This is kind of showing us that to get from 78 to 79 is the same distance as 35 to 42, and we know that's not true. So you need to put it on a number line so everything is spread out the right amount. So you can't just draw it up above. You've got to put it on an actual number line. So we can see, right, this is our part here that's the most compact and together. That means most of our data, 25% of our data, is in that section there. Okay, so now what is going to happen if we add in some more roller coasters here? So I'm actually going to take this guy here. And so we've got them in order, but now we're adding on another roller coaster, 122 and 127. So what do we think is going to happen, right? If we're adding roller coasters that are bigger, it means it's going to shift everything bigger. All the numbers are going to go up on that number line there. So instead of, right, our median was here, it's going to shift towards these bigger numbers because we're adding bigger data. So 35 matches 127. So match. So we're here. So we have got these two. So in the middle here is 77. So now I give this to this side and this to this side. So find our quartile. So we've got to find the middle of these. And so we're going to add 42.5 and 60 is 102.5. Half of that is 51.25. So Q1 is 51.25. And then, so 78 matches 127, match. So we need to add 81 and 100 is 181. And I know 2 can't go in there, so I'll just automatically add a 0.0. So this goes in here 9 times. It can't go into 0, but it can go into 10, 5. So Q3 is 90.5. So if we're looking at these here, we made our new box plot, right? It shifts everything over. So I know it doesn't look like it, but if you take a look at the numbers, we went 77 is our new median. We were only at 68 before. So by adding those taller roller coasters, it shifts everything over. So this is still a pretty big spread here. It's still going to be pretty hard to find a roller coaster that is that really extreme level, but there are quite a few of these challenge roller coasters here. So it kind of shifted everything over. So was the median affected? Yes, the median went up. Was the lower quartile affected? It went from 42 to 51. Yes. Was the upper quartile affected? It went from 79 up to 91. So that was a big jump there that it took. So it pulled everything over. If you add bigger numbers, it makes your data bigger. If you add smaller numbers, it makes your data smaller. Did the least value change? 35, 35. That remained the same. We weren't changing any small roller coasters, but the greatest value did change quite a bit. So we can see, right, there were many different changes just by adding 2 extra pieces of data. So go ahead and complete task 2 and then come back when you are ready to do task 3. Oh, so one thing I do want to talk about, just kind of reiterate here. So this is problem 1. It had 1, 2, 3, 4, 5, 6, 7 pieces of data, right? We found the median and it's just one single number. So we're done with that. So we give it to this side, give it to this side. This is its own number. It's not going to go to either side. On this one here, it had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So these 2 were in the middle. So when we found it, right, it was 68. And we didn't actually, there was no 68 on here that we just circled like this one. So we split this in half and say half to this side, half to this side. You've got to give each of those numbers 1 to one side, 1 to the other when you have an even amount of data. 1 to one side, 1 to the other. If it's odd, there's just 1 in the middle, then you're done with that number. Okay, number 3, so tells us 15 days of temperatures in December in Cleveland, Ohio. So we want to start and order the numbers. So go ahead and put those numbers in order. So 23 is the smallest, and then, let's see, 28, 30, 31, 32, then 34, 34, 34. So 3, 1, 2, 3, 35, 37, 39. Whoops, 37, 39. Then we have, let's see, 41, 56, 57, and 66. So I should have 15 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, since it is an odd number, I know there's just going to be one number in the middle, so that's nice. So let's go ahead and match these up and find your median. So each one matches to another. So my middle is this last 34. The median is 34. So since we used that one, it's done. So now I'm just looking at these numbers and these ones. That 34 is not included on either side. So finding the middle here is 31. So Q1 is 31. And then finding the middle here is 41. So there's Q3. So now we can use this information to make ourselves this box plot. So we draw middle 34, then we draw lower quartile 31, upper quartile 41. So median, lower, upper. Those are your boxes here. Then we whisker over to the smallest one is 23. And then I whisker over to the biggest one is 66 here. So there are my whiskers. So I can see this has a really big spread here. That's telling me that so this is 25% of the data, but it's really spread out. It's saying there's not many days that are going to be over here at 60 degrees or higher in December in Cleveland. Most of our data, right? This is the most packed together place, is between 30 to 34. It's saying most of that data is going to be really packed in there. You can count on a good chunk of the days. 25% of the days are in the 30s. And even look, here's 25. Here's about 50% of the data. 50% of the data, 50% of those days, we can count on being in the 30s in Cleveland in December. So, right, the farther they are spread out, it means there's not as much happening there. When they're more packed together, that means that is a more common data point that you can see. So go ahead and complete task 3. And then if you have any other questions, we're going to keep practicing these dot plots, or these are box plots. So if you have other questions, be sure to let me know and we'll keep practicing. So the biggest thing you want to remember, find the middle. So then break it into 2 halves. Find the middle, find the middle. Those are your 3 lines that you're going to draw. So, right, median, find the middle, find the middle. Those are our lines. Littlest point, whisker, biggest point, whisker. So we will keep on practicing those. So go ahead and complete your check for understanding and have a great day.